Okay, now it's very similar or very easy to prove a very similar equation, which tells you that H acting on A times by E is just E minus omega times by A on E. So if A dagger adds one packet of energy, A removes one packet of energy. Okay, so that's the action of A and A dagger on our energy eigenstates. We've got a single state, and we can add energy to it with A dagger, or we can remove energy from it with A. Okay, now we would like to figure out what are the allowed values of the energy E. We know how to add energy to the state and remove energy from the state, but we haven't yet determined even one energy eigenstate. Now, to proceed, let me consider a specific matrix element, and I want to prove something about it. So let's start off, and psi, I'm going to imagine, is any state. So pick up any state in the Hilbert space, okay? It doesn't matter which state you've got. And I want to calculate bra psi, Hamiltonian, ket psi. I want to study this matrix element. So let me plug in my expression for the Hamiltonian. Remember, the Hamiltonian is omega A dagger A. So this will be equal to, I can pull the omega out. I've got psi, A dagger A, and then I've got psi again. Now, let me introduce a new state. So let ket phi be equal to A times by ket psi. If I dagger this, well, ket phi daggered is bra phi. The dagger reverses the order of states and operators. So the last thing appearing is ket psi. That will become bra psi. And then the A will become A dagger. So in terms of phi, you can see that what I've got here is omega. Then psi A dagger is nothing but bra phi. And A times by ket psi is nothing but ket phi. Now, I want to remind you that we know two things. First of all, the norm of any state is greater than or equal to 0. That's only 0 if you've got the null state. And we know that the frequency of our oscillator is always greater than 0. So that means that this matrix element of psi h psi is always greater than or equal to 0. Okay, so that's the result that I wanted. Okay, so let's study what does this result that we've just obtained, what does it mean if we take psi to be a normalized energy eigenstate E. So the fact that it's normalized means that bra E ket E is 1. Okay, so let's see what we learn. Well, I'll take bra E, the Hamiltonian, onto ket E. Well, the Hamiltonian acting on ket E will just give us E. And then E is normalized. So we just get E. But remember, we just proved that this matrix element is always greater than or equal to 0. So that means that all of our energies will be greater than or equal to 0, which means there are no negative energies. Okay, good. Now, if you have a state of energy E, it's easy to produce a state of energy E minus omega. This, up to some normalization that I haven't figured out, will just be A times by the state E, because A will remove one packet of energy. But if I can produce the state E minus omega, then I can also produce the state E minus 2 omega, which will be some normalization, maybe different to the normalization that I had there. And then I act with E on the state E minus omega. But if I can do that once, I can do that any number of times, and I can keep lowering the energy of my state. Now, of course, if I just keep doing this too many times, the energy of my state is going to become negative. So there must be some state. There must be a state. There must be a state whose energy can't be lowered. There has to be. That's the only way that we can make sure that all of the energies are positive. Let's call that state of lowest energy to be the state E naught. And how the state is defined is that A, if you try to lower the state E naught, you just get naught. You cannot lower the energy of the state E naught. What is this lowest energy? Well, as usual, you would just take the Hamiltonian and act on the state of lowest energy. So this would be omega A dagger A acting on the state of lowest energy. But we know A kills the state, so you just get 0. And that's 0 times E naught. So this is indeed an eigenstate of the Hamiltonian. And we learn that the lowest possible energy is actually naught. Now, remember what I told you. You might be used to the ground state energy being 1/2 h bar omega, but I told you that this -1 subtraction in the Hamiltonian was there so that the ground state energy actually vanishes. And here you see explicitly that the energy of the ground state, of the lowest state, is equal to 0. Good. We'll continue in a moment.